Okay, so you got a track, an air track, and there's a rider. So there's no friction here, right? How much does our rider weigh? How much does our rider weigh? It can be anything. 5 kilograms. No, let's say 500 grams. That's more accurate. So it's 500 grams, and there's a pulley on the end, and the string is attached here. And how much does our mass here weigh? If it weighs just 1 gram, will anything happen?
No. So it's like 1,000 grams.
Think about that. If this is 1 gram,
Oh no, what did you say?
Connor, say that again.
I think that like if there was no friction, it's like 1 gram.
This is frictionless, right?
Oh.
No friction.
So yes.
Ah. Kai, what made you change your mind?
The fact that since the 500 gram block doesn't have any friction, it doesn't really actually have grip on the thing to hold the 1 gram thing.
Right.
So then it just ends up.
If this is in your normal everyday world, this is probably not going to move, right? Because there's not enough force to pull it down. But if there's no friction, there is some force on this down, right? Is it going to accelerate as it moves?
Yes.
Is it going to accelerate at 9.8?
No.
No. Why not?
Because it's not affected by gravity until it falls off fully.
Let's, just because the numbers are so weird, let's make this 100 grams. Okay, and I want you to tell me the acceleration of this system. Go. Take a minute. Grab a piece of paper. Someone try it. Got some lights on for you. Try it. Okay, everybody turn around and look now. Turn around and look. You have 30 seconds to get to your seat. Don't talk, don't move, don't do anything else. Go.
How are they going to move to get
You got 20 seconds left. 10
10
seconds left. Don't talk. Get out paper and pen. Go. I'm being jokey, and it is a Friday that's a Thursday. But I do find it fairly disrespectful that you're coming in late to an 8:45 class when everybody else is here and ready to go. Don't do that anymore. I'm not very consistent, so I can't, I'm not going to train you to be on time, but there will come a day when being late will have a big penalty. And then you're going to be like, why do you go to Pacha? Right now is when I'm warning you. How's that? You okay there? Every once in a while, like once a year, if you were with me for the whole year, once a year I get out to yell. I yell at everybody. And then we kind of laugh about it after. That's as harsh as I get. Not like mean yell or anything. Okay. Really only the cheating. Who's found it? Who got an answer? Who kind of feels like they know what they're doing? Yazzie was the only one who found the answer. Okay. A hint. Remember when we did this? We had the 2 masses on the pulley and we straightened it out? You could do the same thing with this. You can straighten out this system and turn it into kind of a tug of war, except that it looks more complicated, but it's actually simpler, isn't it? What are the forces pulling on this?
Pulling on 500.
On the whole thing?
Oh,
Actually,
Gravity.
gravity, yeah. The only forces acting here are gravity, right? So you have Fg down. And is there anything pulling this 500 grams back? No, there's not. There's no friction, right? Is there a force acting on this at all?
Yeah.
gravity.
Yes. Well, okay, gravity, but it's going to be canceled by the normal force. So we don't worry about that.
It's the 100 grams.
So this thing is going to move. Which way is it going to move?
That way.
To the right. It's going to accelerate to the right. So there must be a force acting on it, is ya?
Tension?
Very good. Excellent. Another golf clap for Nation. You're on fire today. So the FT is pulling it to the right. What does that mean? If there's an FT here, Peria. Excellent. Golf clap for Peria. Everybody's kicking it. Okay, good. So, Azia and Perry are exactly right. You have tension in the string. What would you expect those two tension forces?
They're the same.
They're going to be equal. Good, good. So when we flatten that out, we have Ft this way and Ft that way. And there's really just one net force here, right? We can calculate this pretty easily. What's this force of gravity?
Negative 10.
If we say that G is 10, what's this force? 1,000, yeah, just 100. Well, no, it's not. Gotta be careful.
0.1.
This is how many kilograms?
Oh, you have to convert it.
This is 0.1 kilograms. What's 0.1 times 10?
1.
1. So what's the force here?
1.
1. This is 1 Newton. Right. What is the net force on this whole system?
600.
Thomas.
0.6 kilograms.
No, what is the net force?
6 Newton.
Lilia, what do you think? What forces are acting on the system? Lilia.
Oh,
Yeah.
six,
No.
maybe 6. And
Where did you get the -6 from?
no, not negative 6.
Where did you get that from? How did you get that?
Like 1 and 2 right, and 5 and 2
Oh, so you think there's another force over here?
Yeah.
Is there a force there?
No.
There's not. Why not?
Because there's no friction.
There's no friction. So normally if these, you're right, Lily, if this was hanging, if there were two masses here hanging, then this would have a force of gravity acting on it. But it's being supported by the air track. So does the gravity actually
Is it just 1?
pull it? Azia, say that again.
I said, isn't it just 1?
Is it just one, Sam?
Sorry, just one was.
I don't know. Azia, just one what?
1 Newton. Like the
Just
net
1
force.
Newton.
Because there's nothing on the
Is
other
the net
side.
force just 1 Newton?
Is it 4?
Well, yes.
Isn't it the same
there
thing
the
as it
other
being?
two?
Kai, say that again.
I didn't say anything.
Oh, somebody said. Somebody said it's just 1.
I said.
You said that? Matthew, why is it just 1?
Because
You're right, Azia. It's just 1.
no friction and nothing pulling it the other way.
You could, if you did a free body diagram on this, you could say, yeah, Fg is pulling it down. That's for sure, all the time. But what's holding it up?
No, there's
the normal force, and it's the same, right? So these two cancel out. They're not contributing anything to this acceleration. Yeah, Zeke?
What does abnormal mean?
You put something down, gravity pulls it down, the normal force pushes up. The reason we use the word normal is because in physics, normal means perpendicular. So the normal force is always perpendicular to the surface. So if I put this on a surface like this, and I tilt it, see how it falls over, right? Because the gravity is still pulling in which direction?
Down.
Straight down. But the normal force is this way. It's normal to the surface. So if you tilt it, this is going to slide down, right? Because if you add up those two forces, you end up with a force that way. And that's why things slide downhill. Or at least that's how we represent it. Does that make sense? Okay, so normal means, what does normal mean? Perpendicular. Good, perpendicular. So that's the normal force. So this mass has really, there's a net force on this mass, which is the tension force. But that tension force is canceled on the other end. And so it doesn't really add any net force to the system. The only net force is this. You might think, well, if it's just gravity pulling, it's going to accelerate at 9.8, right? But in this case, it's an interesting situation because the gravity force here is based on this 100 grams. No. The gravity force here is based on this 100 grams, yes? But what's that gravity pulling? Is it just pulling 100 grams? It's pulling 600 grams, right? So we have to, this is kind of weird thing. It's exactly the same as if you had 500 and 100 tied together with a rope, or even glued together, they could be. And if you pulled them with 1 Newton of force, it's actually a really simple calculation, right? And that's how you get the acceleration, the actual acceleration. So who has the answer? How'd you do it? Max?
I got 1.7 meters per second squared down.
1.7 meters per second squared. Who else got that? Ainsley and Yazzie got it. I think that's probably enough. Who didn't get there yet? Okay, I gave you 10 seconds. Go try it. I don't know if that's right. Let's find out. Is this enough? The net force is the sum of all forces, right? In this case, there's only one force. So the net force is equal to this Fg. And so, net force is Ma. And so Ma is going to equal 1 Newton. But which mass do I use?
100.
I got to do the whole thing, right? Then 500 grams is how many kilos? 0.5 kilograms. So what's the total? 0.6.
Wait, do you always have to calculate in kilograms?
If you're going to find acceleration in meters per second squared, you have to use kilograms for mass.
Okay.
Yes.
You do. Okay.
If you're going to work in newtons and normal acceleration, you got to use kilograms.
Like kilograms over newtons, I guess. Does that work in kilograms times?
That's exactly right. This is going to be 1 Newton over 0.6 kilograms, which is, yeah, 1.7 sounds about right. Or 1.6 repeating, right?
Yeah.
Or it's just 1.7.
You could round to 1.7. I'm okay with that. That's fine. Good job, Max. I heard yesterday, I overheard somebody talking, I don't know who it was, but they said, what's the formula for tension? And to my surprise, the person they were talking to told them a formula. They were like, oh, this is the formula. It's T, I don't know what he said.
That was him. He was trolling.
There's nothing inherently wrong with that. I'm not going to bother you about it. But don't fall into the trap of looking for a formula for tension. There are 10,000 different formulas for tension. And the minute that you say, oh, I'm going to memorize a formula and then I'll know what tension is, I put a problem on your test where that formula does not work. And then you're going to get it wrong. So you have to understand the situation. What you can remember is that net force is two different things. Okay? So if you're looking for something to rest on, it's a foundation for all this. Can they see this board?
Yeah. Like half of it.
Maybe I'll just turn. What are the two things in that problem? What are the two things that are kind of the foundational formula type things?
F net.
Good. F net. What does F net equal?
MA.
Good. F net equals MA.
Wait, but does it also equal FG?
In that case, it does. And so why does in that case it equals FG? But last day it was FG and the other FG. Declan?
Yeah, FG's the only one.
In this case, FG is the only force acting on the system. So what can we say? How can we make sense of that? What else is F net?
It's grounding or force. I don't know.
Is every problem involving tension going to have gravity involved? No. What else could there be?
Something dragging something.
Say that again, Ashley?
Or something dragging.
Something dragging, so you could have an applied force.
Friction.
You could have friction. What else could you have? Air resistance, sure. Any force you can imagine can be involved with tension. What can you say about all those forces and the net force?
They're all equal to net force.
Amir, say that one more time.
They're all equal to net force.
Okay, so what do we have to do with them all to get the net force?
Add them up.
Good. The net force is the sum of all forces. So if you add up all the forces on the system, you're going to get the net force. And then you know that the net force is equal to mass times acceleration. If you're looking at the whole system, then which mass do you use? Then you're going to use the total mass, right? If you're looking at just one object, then that will be just the object's mass, but it's only going to give you the net force on that object. Okay?
Wait, could you just do that for two objects and then add them together? Like, would that be another way of solving it?
No. The net forces don't always add together.
I see.
But what is always the same? If two things are tied together,
The acceleration.
good, good. So if, let's write that down just for kicks. If, well, we'll just say, if objects are tied together. This is sort of common sense, but it's nice to write it down sometimes. If objects are tied together, they'll have the same what?
Acceleration.
Yeah. Is he still out there? Or did he give up? keys. Lost them. Crazy. Oh, I've been filming this now too. I'm gonna lose my job again. I think that's good, isn't it?